In Theorem 7, we have to prove that two lines perpendicular to the same plane. In this chair, these two legs serves as our two lines which are perpendicular to this plane which is our floor. Since this line is perpendicular to the plane and this line is perpendicular also to the plane, we can now say that these two lines are perpendicular to the plane. In Corollary 84 states that if each of two lines is parallel to a third line, they are parallel to each other.
Theorem 8. If a straight line is parallel to a given plane, it is parallel to the intersection of any plane through it with a given plane.
Theorem number 8, we have to prove here that this line and this line lies on this plane and cannot meet. This line here is our given line, and the plane which is the floor is our given plane. And this line here is their intersection. Since this line here and the floor is perpendicular, therefore we can say that this line here and this line is parallel. Based on the other book, Solid Geometry by William Schutt, it is supported by Corollary 90. It is stated that if a line outside the plane is parallel to some line in the plane, then the first line is parallel to the plane.
Theorem 9. If each of two planes is perpendicular to the same line, they are parallel. And conversely, if one of two parallel planes is perpendicular to a line, the other is also.
In theorem number 9, we have to prove that the plane which is the ceiling is parallel to the plane which is the floor. First, we have to assume that the plane and the floor are either parallel or not parallel. And we have to suppose that two planes are not parallel. Then, the two planes meet in some line which is containing this point. The reason is non-parallel planes intersect. And there will be two planes which is the ceiling and the floor through this point perpendicular to this line. The reason is given planes, the plane which is the ceiling and the floor is perpendicular to this line. Therefore, we can now say that the plane which is the ceiling is parallel to the floor.
Theorem 10. If a plane is parallel to each of two intersecting lines, it is parallel to the plane of these lines. That this wall is our plane. This is our line 1 and this is our line 2. And that corner is the point of their intersection. So these two lines are parallel to this. Theorem 11. Through a point not in a plane, there is one and only one plane parallel to this plane. In Theorem 11, this is our point not in a plane. It is parallel to this Theorem 12. Through one of two skew lines, there is one and only one plane parallel to these lines. In Theorem 12, all we know that skew lines are two lines which do not lie in the same plane. So let us assume that this wall is our one plane. This is our skew line 1 and skew line 2. So they are parallel to the plane of this line.
Theorem number 13. Through a point outside of each of two non-parallel lines, there is one and only one plane parallel to both of these lines.
In theorem number 13, we have here the two non-parallel lines which are that line and that line. And we have here the point which is not in our non-parallel lines. And through this point, we have one and only one plane can be parallel to this plane, which are that plane.
Theorem number 14. If two intersecting lines in one plane are parallel, respectively, to two intersecting lines in another plane, then the two planes are parallel and the corresponding angles formed by the lines are equal.
In theorem number 14, we have here the two intersecting lines, which are that one and that one in one plane. And then that two intersecting lines are parallel. Then respectively to the other plane. And then this plane and that plane are parallel. Then the corresponding angles formed by their lines are equal.
Theorem number 15. If two straight lines are cut by three parallel planes, the intercepted segments on one line are proportional to the corresponding segments in the other.
Number 15, we have here two lines, which are this line here and this line here. And that two lines are cut by three planes, which are this plane 1, plane 2, and plane 3. And the intercepted segments on line 1 are corresponding segments proportional to the other. It is supported by Corollary 104, parallel planes which intercept equal segments on any transversal line intercept equal segments on every transversal line.
Two dihedral angles are equal if their angles are equal. And conversely, if two dihedral angles are equal, their planes angles are equal.
Theorem number 16, we have to prove here that the dihedral angle, this plane minus this line and minus this plane is equal to the dihedral angle, this plane minus this line and minus this plane. The dihedral angle, which is this plane minus this line and minus this plane here, to the dihedral angle, this plane minus this line and minus this plane, so that these intersecting lines here coincide with these other two intersecting lines. This plane here coincides with the other plane, which is in the second dihedral angle. The reason of that is two intersecting lines determine a plane. This line here is perpendicular to this plane and this plane. Also, this line here is perpendicular to this plane and this plane. The reason is a line perpendicular to intersecting lines at their point of intersection is perpendicular to the plane of these lines. These lines perpendicular to this plane and this plane. And also, this line is perpendicular to this plane and this plane. The reason is, through a given point in a given plane, one line and only one can be drawn perpendicular to the plane. This face of the first dihedral angle coincides with this face of the second dihedral angle. And this face here is also coincides with this
face in this second dihedral angle. The reason is two intersecting lines determine a
Theorem
plane.
17. If two planes are mutually perpendicular, and if a line is drawn from a point, perpendicular to their intersection, then this line is perpendicular to the second plane.
In theorem number 17, we have to prove here that this line is perpendicular to this plane. This plane is our given plane, and we have to draw a line, and this line here is perpendicular with this line. Then this line here is perpendicular with this line at this point, and this is the given. This angle is a plane angle of right dihedral angle. This angle is a right triangle, and this line is perpendicular with this line. The reason is a plane angle is measured by each dihedral angle. Therefore, AB is perpendicular with this plane. The reason is, if a line is perpendicular to two intersecting lines at their point of intersection, it is perpendicular to the plane of these lines. And this is supported with the corollary 103 based on the other book, Solid Geometry by William Schultz. Corollary 103 stated that if two planes are perpendicular to each other, a line perpendicular to the first at any point of their line of intersection lies in the second.
If a plane is perpendicular to each of two planes, it is perpendicular to their line of intersection.